This video is going to go over the second question, the Specimen Paper 2 2014 edition for the IB Math Studies exam. So the second question is a three-dimensional trig question. All of the information that's given in the question is already labeled on the picture for you, so we can jump right into the problem. We have a building here in the shape of a triangular prism, which it says right here. So if you're not sure what shape this is and you're trying to use a formula booklet, it says in the question that it's a triangular prism, and it'll usually tell you the shape in the question. First thing it wants us to do is calculate the size of angle ACB, and that's down here. It is not a right triangle. It doesn't say anywhere in the question it's a right triangle. It doesn't show you a 90-degree angle, so you cannot use sine, cosine, and tangent. You have to use either the sine rule or the cosine rule, because you can use those in a non-right triangle. Here we have three sides, which limits us to having to use the cosine rule. And if you look in your formula booklet for your cosine rule, it's going to give it to you in two different formats. The one of them is already rearranged so that you can find an angle pretty easily. So we're going to set it up using that one. Cosine of the angle we're looking for, ACB, is going to equal 30 squared plus 15 squared, and those two have to be the sides that are adjacent to the angle you're trying to find, minus 70 squared. The one that is subtracted has to be the side that's across from the angle that you're trying to find. This is over 2 times 30 times 50, same two sides that you started with on the numerator. You're going to type that whole fraction into a calculator, and then you're going to do the inverse cosine of whatever you get. So you're going to do the inverse cosine of the value of that entire fraction, which I'll tell you right now comes out to negative 1/2. But you can just type it into a calculator and then do the inverse cosine of your answer that you get. It's not always going to be something as neat as negative 0.5, but here it is. And so ACB is 120 degrees using your calculator. You could get a method point for using the right formula, an answer point for filling in the formula correctly, and then an answer point for, of course, having the 120 degrees. So that's how this thing is worth 3 marks. If you only have the 120 degrees, which you got somehow using a calculator without showing any work, the most points you could get is 2 for using a calculator to get that. Next thing it wants is to calculate the area of the building's footprint, which is the triangle ABC, so the area of triangle ABC. Easiest formula to use, now that we have this 120-degree angle, is area equals 1/2 AB sine C. You can use this in any triangle, as long as you have an angle that is in between or included between two sides. And so we have the 120-degree angle that's included between the 50 and the 30, so that's what we use. Area equals 1/2 multiplied by 30, multiplied by 50, multiplied by the sine of 120. This should be pretty straightforward. And the area is going to come out to, if we go to 3 significant figures, 650 meters squared. So equals 650 meters squared. If you give more significant figures, that's okay, as long as you're rounding it correctly wherever you end it. 3 significant figures at a minimum. Right, for that one again, you can get a method point and an answer point for using the right formula and filling it in correctly, and then an answer point for having the right answer. You can get follow-through points there if you had the wrong angle, as long as you used it in the right formula. Okay. C asks us to calculate the volume of the office block. You're going to go to your formula booklet to find the volume of a prism. This is not a pyramid, even though you see some triangles. It's a triangular prism. Formula, as stated in the book, is volume equals capital A multiplied by H, where capital A is the area of a cross section, which I like to think of as just the base. Whatever the base shape is, which here is a triangle, be the area of that, then all you need to do is multiply it by the height of the prism. Now we already have the area of the base. This is how the IB always sets it up, right? They do it in pieces, so you can use your answer from the piece before. We have the area of the cross section, that was 650 meters squared. And then we want to multiply that by the height of this prism, which if I scroll up, you can see was labeled 120. The most accurate answer would be if I used an unrounded version for B. They'll still give you the full credit if you use your rounded answer from B, but if we use an unrounded one, we're going to be more accurate. So using the unrounded version of that 650, on my calculator it said 649.519 something, something, something. I'll use that, I'll multiply it by the 120, which is the height. and determine that my volume is going to be 77,900. The units on volume are cubed, so that would be meters cubed. The reason these units are cubed, right, think about this one was already meters squared. This is multiplied by another meter. So if you have meters squared times another meter, now your units are in meters cubed. Okay, so here's the volume of a building. To stabilize the structure, a steel beam must be made that runs from point C to point Q. So the first thing we're asked is to calculate the length of CQ. So I'll go back up to my picture. I want to do a bar that goes from C to Q. C and Q are both on that same side of the building. I have a triangle that goes like from C to B to Q. That is a right triangle because this is a triangular prism that stands straight up. So anywhere that the floor meets the wall, you're going to have a 90-degree angle. So here we have a right triangle with 50 and the 20, and we're trying to find the length of CQ. We can just use the Pythagorean theorem. Right? We have the 50 and the 120. So we'll go to 50 squared plus 120 squared equals C squared. And then we evaluate the Pythagorean theorem here in our calculator. CQ, which is our little C right there, is going to come out to 130. The length is just measured in meters. And then the final part of this question says, can you calculate the angle that that line makes with BC? So going back into our picture, the line that angle that CQ makes with BC, that's this angle here. I'm trying to find that theta. I'll be using opposite and adjacent, so tangent. I'm going to set up tangent theta equals 120 over 50. Tangent of theta equals 120 over 50. And then we will use our inverse tangent of 120 over 50 to evaluate that on the calculator, which is going to come out to 67.4 degrees. So this part of the question really has nothing to do with the earlier part of the question. You should be able to get D and E completely right, even if you got the rest of the question wrong. What's important to notice about D and E, of course, is that you have a right triangle there, where you didn't have one on the base. So how are you going to know that you have a right triangle there? All of the three-dimensional figures that they give you on this exam are going to be right three-dimensional figures, which means they stand straight up. So any cylinder, pyramid, prism that they give you, the ground is going to make a 90-degree angle with the height, okay? Because those are the types of figures that you're going to get. And that's all that we're going to cover in this video.